In this video, I'll be showing you guys how to solve for disks and washers when you rotate the disk and washer throughout different axes. So if you don't know how to solve disks and washers about the x-axis, then I highly recommend you check out the video I have in the link description. So right here, we'll have a region of some function, correct? And if we rotate this region about the x-axis, we will get some volume. And you can calculate that volume using disks and washers and with an integral. But what if you want to rotate this region about, instead of the x-axis, what if you want to rotate it about this axis? So instead of rotating it, this region, about the x-axis, you rotate it about this y equals, let's say this is y equals 3 axis. And then you kind of spin it all the way around like so. Well, in order to do that, you can have a very general function for this. And it's actually quite easy. It's actually quite similar to just regular disks and washers. And this function is simply a b as the bounds for your integral with the upper bound function. With the upper bound function, it's actually, I need to find more space with this. Your upper bound function, your right bound function if you're rotating it with respect to y. But upper bound function minus the new axis value. So the new axis y value are, let's treat this as, what should I treat this as? y1 squared minus f lower minus y1 squared dx. So this y1 is just the height of the axes, or the y value of the axis that you're rotating the function about. And why does this work? Well, technically what's happening with this is if you have a function and you have some y value you're subtracting about every single point in the function, then this function is translated downwards by, in this case, 3, right? So if y1, oops, what is that? If y1 is equal to 3 in this case, you move this function down 3 values. So let's see what happens if we move this function down. So if we move this guy downward, this parabola downward, it will look like this. And the new region will look like maybe something like this. Well, if we move the parabola down by 3 y values, well, look what happens. Our region is now below the x-axis. And technically, this x-axis is analogous to our y equals 3 axis. Right? So if we translate everything down by 3, let's translate this axis down by 3 values, we just get y is equal to 0. And that's the x-axis. And if we also translate this function down to get something that looks like this, then we also get the same thing as your previous graph, or this previous visualization, but just translate it down by 3. And then now you can just treat this as a regular washer and regular disk problem, where you just rotate it about a quote-unquote x-axis. But if you really don't care about all that logic, simply use this formula, right? Y of 1 is, we can actually replace this with a better variable. Let's treat it as like maybe r or something like that. R, and r is just the height of your axis that you're rotating about. You can write down a as well, it doesn't matter. Let's write down a since that stands for axis. But in doing so, using this general function with respect to x, then all you really need to do is just write your upper function. So your upper bound function is this green line in this case. Your lower bound function is a parabola, and subtract it by the y value of the axis you're rotating about. So let's go ahead and solve the volume of this washer rotated about the axis y equals -2. So if I were to draw this out just to help you guys a little bit, we have the parabola x squared. We also have the straight horizontal line at y is equal to 4. So this is our region right here that we're rotating about the axis y is equal to -2. So it's going to be in some -2, negative y quadrants. So what happens if we rotate this about the axis y is equal to -2? Well, let's use our general formula. pi AB. Well, we need to find AB. Let's go ahead and find that later. What are your upper bound? What? I missed the pi symbol. All right, what's your upper bound function? Well, your upper bound function is simply 4. So 4 minus, remember, the y value of the new axis. So 4 minus -2 squared minus your lower bound function, x squared. So lower x squared bounds this region from below, minus -2, the y value of your new axis that you're rotating about, squared dx. And what are your x values that bound this? Well, the x values that bound this function are simply here and here, but we can solve this because these are the intersection points between the graphs x squared and 4. So that means x squared is equal to 4. So if we take the square root, we get plus or minus 2. So we take the square roots on both sides, we get the plus or minus 2. So plus or minus 2 are the bounds for our integral. All right. Really, after you set up past this point, your teacher likely will just tell you to set up the problem. So I'm not going to solve for this integral. It's a little annoying algebraically, but essentially if I were to simplify everything, it would look like this. So for this problem, we have the function y is equal to 1 over x. Let's draw the graph. Y is equal to 1 over x looks like this. Standard basic function. And y is equal to 0 is along the x-axis. So x is equal to 1 and x is equal to 3 are just simply vertical lines at the x values 1 and 3. 1, 3. Therefore, our region is bounded here. All right, let's go ahead and set up the integral. So pi from the integral times the integral from 1 to 3. And 1 to 3 is our bounds to the integral because those are our left and right bounds of our region. All right, once you have this, you want to use the general formula that you memorized. The upper bound function is 1 over x. And remember, we are rotating about y is equal to 2. So this right here would be about, what would be a y equals 2. So we subtract our upper bound function by the y value of our new axis, and then square, minus our lower bound function, which is just 0. So 0 minus 2 is just -2, but -2 squared will cancel out the negative. So if we simplify this integral, we get 1 over x minus 2 squared minus 2 squared dx. But I don't think you guys really need any more help on this. Honestly, you don't even need to understand the concept. You can just look at the formula and then use your knowledge about disks and washers already to solve for this, the rest of your problems that you'll get in your college career. But honestly, this topic isn't too hard. If you already understand what disks and washers look like, you just simply rotate about a different axis, and that axis is simply just subtracted from your function. Each of the function values and then squared. So if you're still confused, just look at that general formula at the beginning of the video and take it at face value. But as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. I'm going to play Grow a Garden and get 9 mutations on my Rosy Delight.